So this video shows you another example in equilibrium problem. The problem says two cylinders of diameter 60 mm and 30 mm weighing 120 Newton and 40 Newton are placed in a channel as shown in figure. Assuming all the contact surfaces are smooth, find the reactions at A, B and C. So now see the diagram. Two cylinders of different sizes marked as 1 and 2 is placed in this brown color channel which is 72 mm width. So for solving the problem, the first step is identifying the forces and drawing the free body diagram. Here this problem consists of two cylinders, so we have to draw free body diagram for two cylinders separately. First let us go for first cylinder. The procedure is as usual. First force is weight which acts from the center of the body, and the second force is reaction. See, this cylinder is touching at A, B and one more point here. It was not mentioned, so we will mention the point as D. So in these 3 points the reactions will act towards the object. So first draw line of action from those points to the center. It will be easy to identify the forces in correct direction. So line of force action were made. Now the reaction at A will act like this towards the object, and reaction at B will act like this towards the object. Both are perpendicular to the surface. And the third reaction at D is normal to the roller. So that's all the forces in roller 1. So now the x and y axis will be considered like this. Now the free body diagram will be made separately by considering the xy. The center point will be the center of the object, and the forces are identified here at correct places. Now the forces has to be simplified as pulling forces. So by using law of transmissibility, I had made the free body diagram like this. So the angle for RB line is, already we know, the angle between the RB line and W1 will be equal to the inclined plane. So it will come here. So that will be equal here also 45. So 90 minus 45, I placed it here. Now the angle made by RD line is to be calculated from the geometry of the figure. See, let us take the diagram, given diagram, and this RD force lies in the line which connects the two centers of the cylinders. So now I will draw a right angle triangle here connecting the two centers. I have already noticed this. Whenever you want to find an angle, try to draw right angle triangle. When the two sides of the right angle triangle are known, by using trigonometrical relation we can find out the angle. Okay, so let us say the angle here is required. I assigned it as theta. Now the hypotenuse side was easily found because see the geometry, it is equal to radius of cylinder 1 plus radius of cylinder 2. The diameter is given, so R1 is 60 by 2 30, R2 is 30 by 2 15. So R1 plus R2 will be 45 mm. So hypotenuse side will be 45 mm, and see this width is given as 72. Okay, this width. So if you minus this R1 and this R2, you will get this adjacent side. So it is 72 minus 45 will come 27 mm. So thus we found two sides. Now cos theta equal to 27 by 45 will be the relation. By using that, theta can be found, which comes here as 53.2. So 53.2 is the angle made between the line and the x-axis. So the same was taken this side. Now the free body diagram for roller 1 is over. We have to draw free body diagram for roller 2. Let us take the diagram as fresh. We have to follow the same policy. Identify the forces. So weight two spots where the reactions will take place and they will come like this. Now by using this, draw the free body diagram separately. Both the RD line is same for both of the rollers, hence the same angle is taken here. So thus we have drawn free body diagram for roller cylinder 1 and free body diagram for cylinder 2. We can also keep this free body diagram here, so that both the free body diagram has been merged. Okay, because RD is acting in the same line of action which connects the centers of the cylinder. Weight as W1 120 Newton and W2 30 Newton. Now there will be a question, which free body diagram we have to solve first. You have to solve the free body diagram which is having less number of unknown. Second free body diagram is having two unknown. First free body diagram is having three unknowns, RA, RB and RB. So we have to solve the second one first. If you solve by using our regular procedure, by resolving the forces and addition of forces, then mathematically comparing the equations, you will get RC as 22.4 Newton and RD as 37.5 Newton. Now the RD value is same for both the free body diagram. So substitute the RD value here in the first free body diagram. Thus the first free body diagram will become with the two unknowns. Now you can solve the first free body diagram with our usual procedure. So I request the students to do the mathematical calculation and find the value for RA and RB. Thank you.